Hey guys, and welcome to the Plumbers of Data Science podcast. I'm your host Andreas, and today is a topic that actually comes out of one of my coaching sessions from last week. It's about why testing is so difficult for data engineers or in data engineering. We were talking about this, and we started with the coaching last week, and at the end of the session, we did a bit of a Q&A, and this was actually a topic that came up and that stuck with me. So I think it's a cool topic to talk to you about this. Now, test-driven development, TDD, also called. Now, what is this? The idea with this is you write the tests first before you write your code. Because when you do this, you're immediately thinking about the results, right? What problem do I have to solve? When is it positive? When is it negative? Basically, how does the result need to look? And because you're doing this first, before you're actually writing the code, it's very positive upon the whole development cycle. Now, how do you do this? You first write the test, then you write a minimum version of your code, and then you can basically improve upon this. And whenever you then run the tests, you immediately see, am I doing something wrong, or is this still working? It also helps you with refactoring the code. So if you need to do major changes, you have all these tests running, and this way you know, is my program still working, right? So this is something not really connected immediately to data engineering. This is for software development, a strategy that you use. Now, what are some key benefits of test-driven development? Improved code quality, right? You need to first think about the design and the requirements, and then you can build your code more clearly. You have a strategy of what exactly you want to solve. It's very quick or very easy to detect bugs. Because you have the tests while you code, you can see immediately if something goes wrong. And also the third big positive, and I mentioned this already, refactoring. Now, if you need to make major changes, you still have the tests. You can very easily make changes to your code and still see if it still works or not. Also, some people say better code coverage. This is also because the tests are a prerequisite for writing the code. So naturally, more of your code is actually covered by tests than without. Now, here comes the problem where people are not using it. Right? Because if it's so great, why are people not using it? So the problem is initially, this is a slowdown. Right? People like to start coding immediately and bring their ideas into the code. If you do test-driven development, you first need to look at the requirements and write the tests. So the actual writing of code is coming later. And this feels for many people that test-driven development actually slows down the process for them. And they think it's quicker to write the code first, which might in some cases. But that's usually how this feels. This is also how it felt for me always when I tried to do this. Also, one of the problems that you very often have is just the time, because there's not a lot of time to develop. The focus from the whole project is always on immediate delivery as fast as possible. So this way, in a fast-paced development cycle, it's difficult to package in or difficult to start with the tests first, because you can spend a lot of time on the tests, making the tests good, and then you don't have enough time for the actual coding anymore, right? And also, if the leadership doesn't care about the test and just wants to have the code delivered as fast as possible, this falls off or will not get used, right? It's also very difficult to measure the success of test-driven development, because how do you measure this? How do you measure increased maintainability? It's easier to maintain, that you have fewer errors in your code, that the design is better, right? How do you quantify this? It's very difficult to do. So it can make it very difficult for management to justify the extra time and the extra effort in this. So this is one of the big problems. It feels slow for the developers, and it also feels unnecessary for the management. And so forget about it, which is not good. So you should write tests. But now let's get from software development to data engineering. Is this as easy to use for data engineering or for data engineers. The problem is no, because we have a few challenges in data engineering that are different from simple, in quotation marks, software development. And there are like three major things that we deal as data engineers with this. We deal with large and unpredictable data very often. So unlike traditional software where it's usually small, predictable data, we deal with large and complex data sets, which make it difficult. Also, creating mock data that accurately reflects the original or the live data is difficult. So we are trying to work with representative sample data sets to test, and with mocking larger data sets. So this is difficult because the data is large and unpredictable very often. We are working with a lot of external systems. That's number two. External systems, the data pipeline that we usually build needs to get the data from somewhere. We need to write the data into somewhere. The whole transformation and everything in between is not everything, right? So there are systems or there are components of the pipeline that we don't manage, right? So data pipelines often rely on external systems like databases, APIs, message queues, and testing these integrations, getting the data from the API. Is the integration well? Is the integration to the database well? Does it work well? That is very often problematic, right? So what people do is they either try to create mock database or test databases, test APIs to then test against those. That is something. Also, some other solutions here is external systems very often that you have mirrors of these, right? Oftentimes a solution also is to just test on the live system, right? You still get the data from the live database, but you're not going to write this into the production system. Especially when you're working with message queues, for instance, it is easy to write in a development environment a piece of code that actually gets the data from the live system and then works with it. So there are solutions to this, mocking something, creating test environments that actually work like the external system, or you just use the external system for the testing, which can be tricky, of course. That's something. So two things. We talked about dealing with large and unpredicted data. We were talking with integration of external systems. And now the third thing that is always a problem is changing data. I mean, everybody who's doing data engineering knows the data isn't static. It's very difficult to write a code that works for eternity. Data is changing. For instance, APIs are going to deliver you different data. Maybe they're making changes to the database that you query the data, and they're making changes in the database design. So this will then be problematic for you. So it can be that the tests work, that the tests don't work, that you have unpredictable failures in your pipelines. Sometimes the data will be delivered correctly from the API. Sometimes the API will leave out data, will not send you a part of the data. Sometimes is that the actual structure of the data is going to change without you knowing it. So that's always a problem. One of the solutions for this is actually that you take snapshots of the source and you use that for your testing, so that you have test data from time to time. Take snapshots and then use these snapshots for the testing of your pipelines, of your development. Now, let's quickly go a bit deeper into how test-driven development can be applied to data engineering, right? Because we were talking about the challenges. What are some things? Immediately, first thing, write tests for data transformations. That is how you usually, or I would say most often, use test-driven development. You have some data, you need to do transformations. You actually first write the tests for the transformation because you know the input, you know what the output needs to be. Write a test there. It's very productive to do this. Then very often we have to test data pipelines, right? The problem with that is data pipelines usually not just have like I just mentioned, a transformation. They are multi-stage pipelines. So you need to test each of these stages in a pipeline individually. So you would test the extraction of the data or the data integration. You would test the transformation. You would test the loading. When you think about an ETL process, extraction, transformation, the loading, you would test each individual stage and then see if all the tests work. You would go and you would say, like, if there's a message queue in there, you would test if the message queue actually delivers you the exact same messages that you put in, and so on. So the bigger the pipeline becomes and the more tools are in there, the more difficult it will become for you to test this. Then the third thing, very often we have to mock data sources, right? Often you need to run tests in isolation, so you're not working on the live system. You have tests that use some data or a data source that is not live, and we need to actually create mock data sources, create mock APIs, and these APIs then deliver us mock data, so generated data that looks like the original data. Some people also say synthetic data. So mock data is one thing. Synthetic data is also an interesting topic. I have actually a video about synthetic data, or it was a live stream on my YouTube with mostly AI, what are they called? Yeah, so that's one of the things. Also, very often what we're implementing is data validation or schema validation, so that you understand, okay, there are JSONs coming in. Is that schema of the JSON still the same schema? Is the schema of the CSV that is coming in still the same schema? So you know immediately once something has changed, from extraction to actually loading in an ETL job as example. So you can write tests for the incoming data that validates the actual schema of the incoming data first. And then you would write the next stage test for the schema of the transformation, schema of when you load the data. And this way you can go step by step and validate the schema. So schema validation, a big point that you do. Also, one thing, but this is a bit difficult, is performance testing. Well, usually you write these tests in test-driven development to make sure that your code is correct and that the results are correct, right? But you can also write tests to make sure that your processing is done in a certain amount of time. Now, of course, within data engineering, this sounds easy, but when the data sets get big, when there's a lot of data pumped through your pipeline, this will become problematic, right? Because your process now has to manage a lot of data or process a lot of data. And the last thing that I was thinking about, and this is also something that we often have, is that you're testing the actual data. So you understand not just the schema that we've also done before, you're testing, like, is there missing data in your data set, right? Are there duplicates in there? Is there some records that are malformed in your data set? So basically the logic, is the actual data in your data set okay, or is it corrupted? That is something we also need to do. And because this will get problematic, because the data is so big and so fast that we send through, this is a problem. Now, what are some solutions? Which topics or which tools can you use for these problems, right? Dealing with large unpredictable data, integrating with external systems. We talked about changing data, these three things. What can you do? What are tools that you can use? For dealing with large and unpredictable data, pandas, PySpark, for instance. You can use these for building, manipulating test data. You can use these libraries to create mock data or mock data sets that you actually use. So this is something where you can test then your transformations, your aggregations, and so on and so on. So libraries in this, what you could use here, for instance, also you could use Faker. Faker is a very often used library to use to create fake data, fake names, fake emails, fake dates. And this way you create a fake data set. Now, of course, it depends on your use case that you actually have. Also, dealing with unpredictable data, a big thing that you use, and I, for instance, have this in my Python for Data Engineers course, or I have this in the DBT course, use Great Expectations. Great Expectations is a great tool for validating data, for documenting, for profiling your data. So it can help you actually with the tests, and it's a a good thing to figure out, is the structure right, is the format right, figure out problems with the data. It would see if columns contain nulls, if values fall within a certain range. That's what you can do with these checks through Great Expectations. Now, with integration with external systems, I was doing a bit of research. You could use mock libraries, PyTest mock, for instance, so you can write mock unit cases, or unit test.mock is the library where you can mock, or you can basically simulate API calls and so on, or external dependencies. Now, as I said, I'm not super familiar in this. Test containers was one thing, is the library that allows you to create basically Docker-based containers for your tests. So you could spin up a temporary Postgres or MySQL database and then run this without actually relying on your infrastructure. There's also something like that's called Local Stack. That's a fully functional AWS cloud stack that lets you basically simulate S3, DynamoDB, and Lambda as a service. And of course, it's super helpful if you're developing on AWS. Right? Now, again, then we have the two now. We were talking about external systems, solutions. We were talking about unpredictable data and large data. Changing data. What can you do with changing data? Of course, as I mentioned already, Great Expectations is a super cool tool to actually figure out, has my data changed? Has the structure changed? Or the schema. Great Expectations is the Swiss Army knife here. You can use Airflow to actually use test mode in your DAGs to see if your pipelines are going to fail and what's happening there. And also one thing that I also experienced with DBT, you can see that in my DBT course, also in combination here with Great Expectations, DBT as an ELT tool, right, where you do the transformations actually in your analytics store. You can very easily write tests in DBT and see if your outputs actually work, or if your DBT models actually work. And you can write these tests just with DBT. There are also libraries like Great Expectations that you can use in conjunction with DBT. And this way you can really very good or very well manage your pipelines and manage changing data. Yeah, so I hope this was helpful for you. Again, test-driven development is a cool tool in our data engineering or in our software development belt. First, think about what are the requirements, create the tests for the requirements, and then create the code. There are a bit of problems for us as data engineers. We need to deal with large and unpredictable data. We need to think about integration of external systems. Data is changing as well. So these are problems that we have to face. And also that our pipelines are not just a simple transformation, but there are usually multi-steps pipelines that we have to work with. Yeah, I hope this was helpful for you. Let me know in the comments on YouTube if you have questions around this. I would love to get your feedback. Also, otherwise, hit the like and send this to a friend that can help it. That would be very cool. So, see you in the next podcast next Monday.